Okay, this is question 1C from chapter 5E. We're given the matrix 1, 2, 1, 2, 0, 4, 3, negative 2, 5. So I'm just going to call that matrix A. So first thing we need to work out is the determinant. So the determinant will be the 1, then we need to write the 0, 4, negative 2, 5, which are the columns that are not included under the 1. Then the sign changes, so we go plus, minus, and then the last one will be plus, so 2. Then these will be 2, 3, which is from the columns not under the 2. And then the last one is 1, and the numbers will be 2, 0, 3, negative 2, which are the columns not underneath the 1. So now we work at the determinant as normal, so we'll have 1 times 5 times 0, minus negative 2 times 4, take away 2, then we do 2 times 5, take 3 times 4, plus 1 times 2 times negative 2, take 3 times 0. So that will give us positive 8, plus 4, take 4, which will give us a determinant of 8. Then for part 2 we have to work out the cofactor matrix. So first of all I'm just going to set it up. We're going to have a series of 3 by 3s. And the signs will alternate. So the first one here is a plus, then the next one's a negative, the next one's a plus. Then going down we alternate, so negative, positive, negative, negative, positive, and then positive, that's right. So we've got plus, minus, plus going down, negative, plus, minus, plus, and we'll have 0, 4, negative 2, 5, 2, 3, 4, 5, 2, 3, 0, negative 2, which is what we had just done in the first part of the question, finding the determinant. For the next one, we'll look at the 2 and the second one, and we need to include the numbers 2 and 1, negative 2 and 5, so they're not in the same row or column as the 2. Then our next number is the middle 0, so we need to include the 1 and the 3 and the 1 and the 5 that are not in the same row or column. Then we'll have 1, 3, 2, negative 2, following the same process. We're using the numbers that aren't in the same row or column. Then for the 3 in the bottom corner, we'll need to use the 2, 0, 1 and 4. Then 1, 2, 1, 4, 1, 2, 2, 0. So each time using the numbers that aren't in the same row or column. So the next step, we need to work out the determinant of each of these. So for the first one we'll have 5 times 0, take away negative 2 times 4, which will give me positive 8. Then we've got 5 times 2 is 10, take away 12 would give me negative 2, but we've got this negative, so that makes a positive. Then 2 times negative 2 is negative 4, and then the next one we have 2 times 5 is 10, take away negative 2 times 1, so that gives us 12, but we've got the negative here, so that gives us negative 12. Then 5 times 1 is 5, take away 3 will give us 2, 1 times negative 2 is negative 2, take away 3 times 2, and that will give us 8, but it's going to be a negative 2, take away 6 is negative 8, but the negative makes a positive. 4 times 2 is 8, then we've got 1 times 4 is 4, take away 2 would give us 2, but we've got the negative to make a negative 2. Then we've got 0, take away 4 to get negative 4. So that is our cofactor matrix. Then the next thing we need to work out is the adjoint. So the adjoint of A is equal to the transverse of C. So to find the transverse, the numbers that are on the top row become the first column, so the 8, 2 and negative 4 go downwards. Then the numbers that were in the first column become the first row, so we'll have the negative 12 and 8. The numbers on the diagonal don't change at all, and then we switch the positions of these other ones. So the 8 that was on the last row on the last column becomes the last row, and the negative 2 from the last row becomes in the last column. So that's our adjoint matrix. Now, finally, to find our inverse, the inverse of matrix A is equal to the adjoint of A divided by the determinant of A. So the determinant was 8, so I've got 1/8 of the 8, 2, 4. So an eighth of 8 is obviously 1. 2/8 will give us 1/4. 4/8 would give us 1/2. Oh, and I've dropped the negative sign. 12/8 would be negative 3 over 2. 2/8 is 1/4, and 8/8 is 1. 1, negative 1/4, and negative 1/2. So that's our inverse of A.